Hi guys, today we're going to be solving equations, but I want to start with a question. When you solve an equation, you know the rule is whatever you do to one side of the equation, you have to do to the other side of the equation. My question is, what is that all about? Why is that a rule? So consider that, ponder that a bit as we get started, and we'll talk about that as we go. So here we go. Let's look at these problems, and let's dive right in. So we have x minus 12 equals negative 3. So how do you do this kind? You want to get x by itself, right? So we just add 12 to both sides. That will get rid of the negative 12. Okay, so I'm going to write that in red. Okay. And what we get then on the left, just as we intended, negative 12 plus positive 12, 0. That goes away. It just leaves the x. And over here, negative 3 plus 12 is 9. Okay? That a little bit neater. Okay, let's go ahead and check that. It's a good idea. If you have time, just check them, right? And how do you check the solution to an equation? Plug it into the equation, see if it's true. After all, what we were wanting is a value of x that makes this equation true. Let's see if 9 is that value. So put a 9 in wherever x is. So it's instead of x minus 12, it's 9 minus 12. Let's evaluate that. 9 minus 12 is negative 3. It is true. So x equals 9 is a solution. It makes the equation true. Okay, let's look at the next one. So how do we do this kind? We x divided by 10. We want to get rid of the 10, right? So we multiply both sides by 10. And we could squeeze that in up here. I'm going to just rewrite it. Have to be very careful, write it down correctly. I'll leave room for writing in some red. Switch to red. And it occurred to me, you could get colored pencils and actually do this. It might help prevent errors, make it look pretty. If you're inclined to do that, if it makes it more fun, I would encourage you to try it. So we'll multiply both sides by 10. And on the left, just as we intended, the 10's cancel. You have 10 in the numerator, 10 in the denominator. And the effect of that is, well, we're dividing by 10. We're also multiplying by 10. They cancel out. It's the same thing as just multiplying by 1, right? So it just leaves x. On the left, 320. And we're done. We have our answer. Let's check that one. Okay, we're going to put 320 in. Oh, I wanted to go blue. $320 in for the x. So it's 320 divided by 10 equals 32. See if it works. It does. Life is good. Okay, let's go on to the next one. So here we have a negative 4 we need to get rid of. If we can do that, x will be by itself, and we will have our solution. So we divide both sides by negative 4. Just so I won't be changing the original problem statement with my writing, I'm going to rewrite it. Okay. Divide both sides by -4. And on the left, as we intended, we just have x remaining. On the right, 64 divided by -4. That's a positive divided by a negative. It's going to be a negative. And it's going to be -16, right? Okay, we'll check that. -4. Oh, got the wrong color again. -4 times -16 equals 64. All we did was plug in the -16 for x. Negative times a negative. That's a positive, right? 4 times 16, 64. Positive 64 because negative times negative. And it checks. Okay. One more in example 1. And this time we want to get m by itself. It's simply added to 7. So we need to get rid of that 7. We're going to subtract 7 from both sides. We write it down like this. It's sort of a handy way to write it when you're subtracting the same thing from both sides or adding the same thing to both sides. You could also rewrite the problem and put it in horizontally, and I kind of like that way, but this way seems to be the more popular way that you've probably seen more. So what do we get? On the left, it's just m. On the right, 64 minus 7, that's 57. Okay. Didn't draw a box around these others over here, so let's do that. And let's see if this one's right. We're going to plug in for m, so it's 7 plus 57 equals 64. We're going to see if that's correct. 7 plus 57 is indeed 64. And that checks. Okay, so we got a few more. So before we start on these, let's just talk briefly about the question I started with. Remember we said if we do something to one side, we have to do it to the other. The point of that is, when you do that, you are assured that the resulting equation will be an equivalent equation to the one that you started with. And so you will have a chain of equivalent equations as long as you obey that rule. Each equation will be equivalent to the one above. Well, what's it mean for equations to be equivalent? It means they have the same solutions. So let's think about that as we do this next problem. Each equation in the chain will be equivalent to the one above, meaning it has the same solutions, And so at the end, when the solution falls out and is obvious to us, we know that all the equations have the same solution, so it also must be a solution of the original equation. So here we go. What's the step we need to do to this one? This is going to take more steps, right? We have to get rid of the 7 and the 3. So which one do we get rid of first? Okay, well, to get rid of the 3, you have to multiply by 3, but you have to multiply both sides by 3. So this, you could do that, but that would be sort of unnecessarily difficult, because you would have to distribute the 3 across both of these terms on the right side. You'd have to distribute it across that term and that term. So that's unnecessarily difficult. We're not going to get rid of the 3 first. We're going to get rid of the 7. So we are going to subtract 7 from both sides. So here we go. Doing the same thing to both sides. You're assured the next equation will be equivalent. It will have the same solutions as the original equation. We get a -1 here, n over 3 there. And now we can get rid of the 3. And to do that, multiply both sides by 3. Leave some room for the red. And it's times 3 and times 3. Doing the same thing to both sides. And when you do the different colors like this, you can see my black exactly matches from this equation to this equation, and I've put in red, and the red is the same thing to both sides. I can check myself that way. And so here we go. So we have -3 here. We have n, and that looks like we're done. Now, I was looking over my notes, hoping that I got it right, because I'm not going to check this one, okay, just to save time. But remember, on a quiz, go ahead and check it if you have time. I checked this already, though, guys. This one is correct. So there's our answer. And this is an equation too, right? It's just a really simple equation. -3 equals n. But because we followed the rules, we know the solutions to this final equation are the same as the solutions to the equation that we started with. And the solution to the final equation is obvious. And when n is -3, that final equation is true. And so we know that when n is -3, our initial equation is also true, because they're all equivalent, meaning they all have the same solutions. Okay, so let's go ahead and do these last two. What do we do here? We want to get the v by itself. The v, though, is inside these parentheses. What are you going to do with that? V plus 2. You do parentheses first in order of operations, but you can't add v plus 2. They're not like terms. Remember, anything that has the variable in it to the first power in this case, of course everything's just to the first power right now. We'll do higher powers later. But Anything with a v can only be added to other things that have the v in the term. These are not like terms. You cannot add them. So what are you going to do? Well, what you have to do is go ahead and distribute. You have to multiply this out. So let's do that. Okay, we take 4 times v is 4v. 4 times 2 is 8. Okay, so now we've got something we can work with. We got to get the v by itself, right? So we're going to subtract 8 from both sides. Okay, on the left, we have only 4v remaining. On the right, we have negative 4 minus 8. And we got negative signs all over the place. Oh my gosh, this is tricky. And you know, I'm kind of kidding, but yeah, this can be tricky. So negative 4 minus 8, well, it's negative 12. But if you have trouble with this kind of thing, what I suggest is turn a subtraction into addition. So let's look at this. We have negative 4 minus 8. So that's negative 4 minus 8. We'll just write it down over here in the margin. And it's got a couple negative signs, and we might get confused. Let's change it into addition. Instead of subtracting 8, we're going to add negative 8. Okay, well now we're just adding 2 negative numbers, right? And we know if we add 2 negative numbers, we get the negative number, which is negative 12. Okay, so now we divide both sides by 4. So I'll rewrite it first, so I don't kind of obliterate that step. That's just a way to maybe make it more clear. Divide this side by 4, divide this side by 4. What we're left with, and that's it. Okay, so we won't check that one either. It's a little more involved to check it, but if you have time on the test, sure, plug it in. We could take a quick look at it and just do it in our head. Put the negative 3 in for the v. Negative 3 plus 2 is negative 1. 4 times negative 1, negative 4. Yep, it checks. Okay, one more. Let's take a look. So what do we do with this one? We want to get the v by itself, but it's added to 3, and then it's divided by 5. Can we do anything with the 3? Think of this big long division bar. That's a grouping symbol, right? It's just like we had parentheses here, because the long division bar means you first do this addition. And so we don't write the parentheses in, but we could. It's just like they are there. So you have a grouping symbol here, and you have to do the addition first, but of course they're not like terms. You can't add them. So we have to multiply both sides by 5. So let's do that. Leave room for our times 5. Okay, so negative 9 times 5 is negative 45. And over here, the 5's cancel. We're left with 8v plus 3. Okay, so we've still got some more steps to go. We need to get rid of the 3 now, right? Subtract 3 from both sides. Okay, we have negative 45 minus 3, a similar situation as we had over here. That's negative 48. And over here, 8v. Okay. And so now we're just about there. Divide both sides by 8, right? I'm going to rewrite it just so every step will be there. Divide both sides by 8. What's left over here? Negative 6 equals v. That's what we were after. Okay, let me check my notes real quick. Since I didn't check these, I want to look at my notes, make sure they're right. And let's see, I think they are. Okay. So again, we didn't plug these in to check them. You plug negative 6 in here for v. That would be 8 times negative 6, negative 48 plus 3 would be negative 45 divided by 5 is negative 9. So checking in my head looked like it's right, and I did check it earlier. Okay, so those are some examples. If you're watching this video because you missed class, then make sure you check Canvas for the homework assignment and all that, and due dates. And that's all. See you later.